Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic Solutions Part 8. This is for class 12 CBSE. Today we will discuss the topic Ideal and Non-Ideal Solutions, and we will also do one numerical. So let us start. First is Ideal Solutions. What are ideal solutions? Now the solutions which obey Raoult's law over the entire range of concentration are known as ideal solutions. In these solutions, the enthalpy change of mixing of pure components, that is, when the pure components are mixed, the enthalpy change to form the solution is 0, that is delta H will be 0, and the volume change of mixing is also 0, that is here delta V is 0, volume change is 0. So whenever the components are being mixed, no heat is absorbed, and when the components are mixed, no heat is evolved. At the same time, the volume of the solution would be equal to the sum of the volumes of the two pure components. Means individually, let us, if we are using the components A and B, then the volume of component A plus volume of component B will be equal to the volume of the solution. That is sums of the volumes of the two pure components A and B. So if you just add them, so the volume of the solution would be equal to the sum of volumes of the two pure components which we are adding. Now, if the intermolecular attractive forces of the two solutions we are using, if the intermolecular attractive forces between AA, that is, now what we are doing, we are using two components A and B. A is a pure component, B is a pure component. Now when the intermolecular attractive force between AA molecules and those between BB molecules are nearly equal to that between the interaction between A and B, what we will get will be an ideal solution. So I will just tell again. So there are two pure components. One is A, another is B. Now in the A component there will be intermolecular attractive forces between the molecules of AA, and also there will be intermolecular attractive forces between the molecules of BB. So this is in one side. At the same time, when we have formed the solution, there will be new intermolecular attractive forces between the molecules of A as well as B. And if both are equal, if both the attractive forces are equal, what we get is ideal solution. For example, as in the case of N-hexane and N-heptane. These are the organic compounds, hexane and heptane. At the same time, there will be another type which is known as non-ideal solution. Whenever there is a solution and it does not obey Raoult's law for the entire range of concentration, we call it non-ideal solution. They do not obey Raoult's law over the entire range of concentration, we call it as non-ideal solution. In this case, what happens when we mix the components, the vapor pressure of such a solution will be either higher or lower than that what is predicted by Raoult's law. If it is higher, it is called as positive deviation. That is, if vapor pressure in the new case after solution is formed, if it is higher, it is positive deviation. If it is lower, it is known as negative deviation. Now we have to see why this deviation should occur. Now if we are adding the components A and B, so before adding there will be some interaction between AA and some interaction between BB. After adding the components, there will be new interactions between the molecules of A and B. Now if these AB interactions are weaker than AA or BB, means what we are saying is the attractive forces between the solute and the solvent molecules are weaker. The new forces which are developed are weaker. So what will happen? the molecules of A or B, they can easily escape than when they were pure, because AA interaction is more, BB interaction is more than AB interaction. So when it is in AB interaction, that is interaction between solute and solvent molecule, this is weaker, they can easily escape and thus increase the vapor pressure. So since they are increasing the vapor pressure, it is positive deviation. Now example is ethanol and acetone when they are mixed. Before mixing, in case of pure ethanol, in between the molecules there will be hydrogen bonding. In pure ethanol, the molecules are hydrogen bonded. When we add acetone, some of the molecules will get inside them, in between, break some hydrogen bonds. So when they break the hydrogen bonds, this new interaction between ethanol and acetone is not very strong. So they can easily escape and thus increase the vapor pressure. So this is positive deviation. Now we come to negative deviation. In negative deviation, the intermolecular attractive forces between pure components A and B, in case of A it is AA, in case of B it is BB. Here what happens? These interactions between AA and BB are weaker than the AB. AB is the new interaction which is formed. That is the interaction between solute and the solvent molecules. The interactions between the solute and the solvent molecules are strong. Initially AA and BB are weaker than that between A and B. So it will lead to decrease in vapor pressure. When there is decrease in vapor pressure, there will be negative deviation. There will be negative deviation. Example is mixture of phenol and aniline. Now, intermolecular hydrogen bonding takes place between phenolic proton and the lone pair on nitrogen of aniline. In aniline there is a nitrogen atom. In that nitrogen atom there is a lone pair, and there is intermolecular hydrogen bonding between the phenolic proton and the lone pair on nitrogen, and this is stronger than the intermolecular hydrogen bonding between phenol or between aniline molecules. Means the hydrogen bonding between phenol and aniline is stronger than the intermolecular hydrogen bonding between phenol-phenol or aniline-aniline molecule. So you see here, this is the first one. These are the two deviations. You see here the vapor pressure of solution, it is more. We can see by this it is marked. And in the second case, this is vapor pressure of the solution, it is less than what is expected. So I hope students you all could understand the positive and the negative deviations. Based on this, let us, related to this topic, we will solve one problem. Now the question is, two liquids A and B form an ideal solution. At 300 K, the vapor pressure of solution containing 1 mole of A and 3 moles of B is 550 mm mercury. At the same temperature, if 1 more mole of B is added to the solution, means A remains 1 mole only, but B we are adding 1 mole again. So it will become 4 moles now. The vapor pressure increases by 10 mm mercury. We have to determine the vapor pressure of A and B in their pure states. So let us solve. Now see, let us say the vapor pressure of A, pure A, PA naught. For B, pure B, it is PB naught. So total vapor pressure here, total vapor pressure of the solution So here solution means 1 mole of A plus 3 moles of B. That will be equal to XA PA naught plus XB PB naught. XA XB are the mole fractions of A and B. So that will be equal to, see, total 4 moles for A, that is 1 mole, so it will be 1 by 4 PA naught plus 3 by 4 PB naught, and the total pressure is given as 550. It is given in question. Now taking 4 as common and shifting it to the other side, what we get is 550 into 4, 2200. This is equal to PA naught plus 3 PB naught. Let this be equation number 1. Now in the second case, when we are adding 1 mole of B again, 1 mole of B. So total pressure now. Total vapor pressure here it is 1 mole of A plus 4 moles of B. Here it is now 10 millimeter mercury increased, so that will be 560. That is equal to, now total moles is 5, 1 mole is of A, so 1 by 5 PA naught plus 4 by 5 PB naught. So taking 5 common and shifting to the other side, we get 2800 is equal to PA naught plus 4 PB naught. Let this be equation number 2. Solving these equations means we can subtract it. From 2 we can subtract 1. So we will get that PB naught is 600 millimeter mercury, then PA naught will be 400 millimeters of mercury. See, if we subtract it, so this is 2800 is equal to PA naught plus 3 PB naught. So below that, if we write the equation number 1 and we subtract it, PA naught gets cancelled. 4 minus 3 is 1. So what we get, PB naught equal to 600 of mercury. So this is the vapor pressure of pure B. PA naught will be equal to what then? 400 millimeter of mercury. Putting the values. So we get PB naught is equal to 600, PA naught is equal to 400 millimeter of mercury. So PB naught is the vapor pressure of pure B, PA naught is the vapor pressure of pure A. I hope students you all could understand the topic I discussed today as well as the numerical. Thanks for watching the video. Please subscribe to my channel and share the video. Please subscribe the channel. Thank you all. Thanks.